Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Conformational equilibria, ring flips, bond rotations, are generally rapid at room temperature because they involve low energy barriers, typically 10 to 12 kcal or less. In contrast, configurational changes, such as CI strands, geometric, isomerism about AC is equal to C double bond, require breaking a pi bond, which has a very high energy barrier, tilde 60 kcal or more, and is not rapid at room temperature. Step-by-step reasoning. Option A shows a ring flip equilibrium of a desubstituted cyclohexane, 1-chloro-4-methylcyclohexane, between two chair conformations. Ring flips involve only conformational changes with a barrier of approximately 10 to 12 kcal, which is readily overcome at room temperature. This equilibrium is rapid. Option B shows interconversion between two geometric isomers, CIS and trans, or E and Z, of a trisubstituted alkene containing Cl, Br, and Me groups on the double bond carbons. To interconvert E and Z isomers about AC is equal to C double bond, the pi bond must be broken and reformed. The energy barrier for this process is approximately 60 kilocalories per mole, which is far too high to be overcome at room temperature. This equilibrium is not rapid at room temperature. Option C shows rotation about AC to C single bond in a Newman projection, ethanolike with methyl substituents, interconverting gauche and anticonformers. Rotation about AC to C single bond has a very low barrier, tilde 3 kcal, making this equilibrium very rapid at room temperature. Option D shows interconversion between the chair and boat conformations of cyclohexane. This conformational change has a barrier of about 10 to 12 kcal and is rapid at room temperature. Why other options fail? Options A, C, and D all involve conformational changes, ring flips or bond rotations, with low energy barriers that are easily overcome at room temperature. Only option B involves a configurational change requiring pi bond breaking, which has an insurmountably high barrier at room temperature. Therefore, the correct answer is A. Therefore, the correct answer is option A.